Alright, number 13. This is a good problem. Aren't they all good problems? We want to find the total mass of the triangular region which has density delta x is 1 plus x. So here's my axis right in the middle here. Here's the origin. Okay, so I've got this, and it's telling me the density at any point x. So whatever x is, that's telling me what the density is of this region. So if I want to find the mass of the region, I can divide it into this little rectangle here, x units away. And we know that the density of that strip, because they're telling me the density of the object, x units away from the origin, is 1 plus x. So the mass of the slice is equal to delta x times the height times the width. Okay, and the width, of course, is delta x. Oh, delta and delta times delta x times the height, whatever that height is. Now, this is where we have to go back and ask ourselves, well, what is h? I need to write h in terms of x, okay, because I'm going to be integrating with respect to x. I need to know that. Well, you need to know that the equation of this line is y equals negative x plus 1 mx plus b, and the equation of this line is y equals x plus 1. So I know the mass of this slice is delta x, 1 plus x, times negative x plus 1, that's the height, times delta x. That's the mass of this one slice here. And so I can add up the slices from 0 all the way up to 1 by just doing this. Total mass from x equals 0 to x equal 1 is given by the integral from 0 to 1 of 1 plus x times negative x plus 1 dx. And now I can only go from 0 to 1 because the height here, that function there, is only valid from 0 to 1. If I want to find the total mass from x equals negative 1 to x equals 0, then I'm going to have to do something real similar, except I'm going to go from negative 1 to 0 of my density times the height over here is x plus 1 times the thickness, which is delta x, which becomes a dx in my integral. So the total mass, I'm going to have to add these two things up. So if you do the first one, which you would multiply this out and then just do the integral, you should get 2/3. If you multiply this out, you will get 1/3. So the total mass is 2/3 plus 1/3 is 1 gram. Alright. Okay, so just to recap, we want to find the mass of each slice, and then we integrate it to add them all up. And I have to do two integrals because I've got two different functions that represent the height. Okay, so I think we can do one more on here. Alright, let's look at 15. 15 says this: Circle City, densely populated, so we've got this guy. Alright, and we know, tells us the density of the population is given by, well, it's in terms of r, so I'll write it like that. Delta of r is 10,000 times 3 minus r. So any radius from the center of r, the density is given by this function. Okay, so if r is equal to 2, say, 10,000 times 3 minus 2 is 10,000 people per square mile. That's anywhere in this band, in this circle, that's the density. That's what that means. Okay, so let's do this, part A. So assuming the population density at city limits is 0, find the radius. Well, that means that we can use the one that set the density equal to 0 and solve for r, and that will tell us what the radius is when the density is 0. So r is equal to 3. So the radius is 3 miles. Okay, B. What's the total population of the city? Well, what is the population of the slice? And then I can integrate from 0 out to 3 and get all of these slices added up. Okay, so the population of the slice is 10,000 times 3 minus r people per square mile times how many square miles in the strip. Well, if I cut that strip and lay it out, it's delta r wide. Right, that's how wide my strip was. I didn't write that before. And how long is this? Well, that's the circumference of my strip, which is 2 pi r. So this will be times 2 pi r times delta r. That's the population of the slice for any given r. And then from there, I can go right to this. The total population would be the integral from 0 to 3 of 10,000. I'm going to rewrite the order, times 2 pi times 3 minus r times r dr. And this actually becomes a pretty straightforward integral. Once you factor out the 10,000 and the 2 pi, it's just you're integrating that. Multiply it out, and if you do that, what will you get? Let me check here. 282,743 people. Okay. All right. Makes sense? If not, let me know.